Hey YouTube, today I wanted to go over some FTP enhancements, some spanning tree enhancements. So in the last video we reviewed some of the basic workings of spanning tree. And now that we have that understanding, what can we do to improve the performance of FTP to make it operate better? Well, one thing you'll begin to notice when working with spanning tree is that a port that faces an end user will take 30 seconds before it begins forwarding traffic. That is just way too long. So the first enhancement we're going to talk about is portfast. So what portfast does is it skips the listening and learning state and immediately puts the port into a forwarding state. So this is extremely useful when we're connecting it to our endpoints. So to configure this at the interface level, we're going to go there, configuration mode, interface, in my case Ethernet 00. We're going to try spanning tree portfast. And that's now put our port into this portfast mode. So this will be an individual port at this mode. So what if we want to make the entire switch like that? Luckily there is a global config mode command that does that. So let's go back to global config, and the command here is spanning tree portfast default. All right, all done. The global command will put all of our ports into portfast, but it will not put a trunk into portfast. So knowing this, a port that is connected to a hub or a switch that is an access port needs to have portfast turned off. So the command to do this is at the interface level. So let's go to one of our interfaces. I'm going to pick on Ethernet 00 again. And the command to turn it off is spanning tree portfast disable. All right, and to verify what state our ports are in, there's a couple commands. So one command we could do is, get out of this, show spanning tree interface Ethernet 00 portfast. It's disabled. So let's show you one that has it enabled. We'll go to 01. Enabled. And we could also do show spanning tree VLAN in your VLAN number. So in my case, I'm going to show 10. We can see here that access ports are now listed with this SHR edge or shared edge. So this is a quick way to see if you're in portfast, because that edge keyword tells us that it's in portfast, is enabled on this port. We can also use the command show spanning tree VLAN 10 summary. And this command is an excellent command. It gives a lot of information, and right here we can see portfast default. And another command you can use, it shows a lot of detailed information, but it's, I think, sometimes a little too detailed, is show spanning tree interface Ethernet. I'm going to use 01 in my case. Detail. And then you can tell on this third line from the bottom that the port is in portfast mode. So now we've shown how to configure portfast. What else should we know? Well, when we configure portfast, these ports will automatically go into a forwarding state right away. But there's a possibility that someone could have plugged in a switch on the other side of this port, and that could cause some issues. So there's a couple commands that were created called bpduguard and bpdufilter. Now, of those two, the more common one that I've seen at least is bpduguard. So what bpduguard does is, if it receives a BPDU, it puts that port in air disabled state. So it'll just shut down the port. Now, what bpdufilter does is, well, it does exactly what it sounds like. It filters out BPDUs. So this means that it will filter all incoming and outgoing BPDUs from an interface. Now, this can be dangerous if you don't know what you're doing. So that's why I generally have seen bpduguard. So for both of these commands, like portfast, there's a global configuration command and an interface level command. So for bpduguard, the global command is, let me go back into config mode, spanning tree, portfast, bpduguard, default. And now it's the same exact command if you wanted to do bpdufilter. It's just filter instead of guard. I'm not going to use that one. So yeah, we're just going to stick with bpduguard. And then at the interface level, we can go to an interface. I'm going to pick on 0, 0 again. And we can do spanning tree bpduguard enable. And conversely, to remove it, it's disable. And now this is the exact same command, except for instead of bpduguard, it'd be bpdufilter. So, as you can see, the feature can be turned off on a port if it's configured globally. And also note, for the global configuration of these features, it is dependent on having portfast enabled. Interface level does not require portfast to be enabled for the feature. So just remember that if you want to turn it on globally, you have to have portfast on as well. And now what we can do to verify bpduguard or filter, we can use the show spanning tree VLAN, I'm going to use 10 in my case, summary. And it shows now bpduguard is on by default. Or at the interface level, we could do show spanning tree interface Ethernet 00 detail. And then, oh, I turned it off on that one. Let me go to 01. It shows that bpduguard is enabled by default. Okay, so another useful enhancement to spanning tree is uplinkfast. Now what uplinkfast does is if a switch has two uplinks to the root switch, one directly connected and maybe another through another different switch, if the root port loses connectivity, by default the other link that will become the root, and now generally would have to wait the 30 seconds for the timers, will automatically become the root. It'll just immediately go into a forwarding state. So the command to turn that on is, let's go back to config mode, spanning tree, uplinkfast. And now just to verify that this command's working and we're in that state, we're going to do the show spanning tree summary command again. And we can see now uplinkfast is indeed enabled. And we could also use the show spanning tree uplinkfast command. And since we had multiple ports, we actually see that, you know, it's enabled. As what's our forwarding port and what's the backup. Okay. Another useful command to use is what's called rootguard. Now this command is an interface level command that will block BPDUs that have a better priority that could make, say, the downstream switch the root. Now this command will then put that spanning tree port in a root inconsistent state for the VLANs that had the better priority, since we do a per VLAN spanning tree. Okay, so what that means is that the switch will just keep listening to the BPDUs but won't forward traffic out that port. Now, the command to enable this on an individual port is, let's go to an interface. We'll continue picking on this one. Spanning tree guard root. Now, this command is generally placed on your distribution or core, wherever you want your root to be, to your downstream switches, just so if someone plugs in a device that tries to take root, it can't. Okay, so what can we do to verify that this command is enabled? We can use the command let me get out of config mode. Show spanning tree interface. I'll use Ethernet 00 again. Detail. And here it shows that rootguard is enabled. Now, if we wanted to see if there was a port that's in that inconsistent state, the command we could use would be show spanning tree inconsistent ports. Now I don't have any inconsistent ports, so I'm not seeing that. Alright, so the final commands that I want to bring up, one's for spanning tree, and another one's similar, but it's not spanning tree. It's called UDLD, but I'll get into that in a minute. Now these two technologies are very similar, but kind of work at a little bit different levels. So we'll start with spanning tree, which is called loopguard. So loopguard is designed to keep loops from occurring. So the loop can occur when there are two redundant connections going to a switch, and one of the loops stops sending or receiving these BPDUs, and the other redundant port goes active. So this is like two connections going to this, the same switch has two connections to like the root switch. So this can happen if there's like a physical cabling issue, like if it's fiber or someone turns on bpdufilter and it stops, sending and receiving BPDUs, so it thinks it's not down, but it's not receiving the BPDUs, so it's going to turn on the other interface, and this can cause a loop. So to enable loopguard, it's a global configuration command. So let's go back in and type spanning tree loopguard default. Now the other command I mentioned, UDLD, this works on the physical cabling itself, where it will send out hellos on the port to verify that the link is not unidirectional. UDLD stands for unidirectional link detection. So by unidirectional I mean only one half of the link is working. So like if it's a transmit receive, we're only sending and not receiving, or vice versa, receiving and not sending. So UDLD must be turned on both switches for it to operate. And the command for turning on UDLD is UDLD enable or UDLD aggressive. Or you could do this at the interface level using the UDLD port enable. Let's go to a port. UDLD port enable or UDLD port aggressive. Now aggressive mode, like the name suggests, is more aggressive about sending out the hellos in an attempt to verify that the neighbor is down. Enabling this command globally only turns it on fiber ports. So if you want UDLD on say a copper port for some reason, you have to do that on a per port basis, and it has to be done on both sides. So both switches must support this UDLD. And then to do some verifications, we can do what we've done many times, the show spanning tree summary command, and we can see loopguard is enabled by default. And then to verify UDLD, since I can't use UDLD on this virtual switch, the commands are show UDLD neighbors or show UDLD, and then the interface type and number, so like Ethernet 00 or gig Ethernet or 10 gig Ethernet, and then you'll get the details for that interface. So in this video we covered a lot on the spanning tree enhancements, and now in the next video what I want to cover are some of the newer versions of spanning tree, rapid spanning tree, and multiple instances of spanning tree. So thanks for joining me. I'll see you next time.